Okay, so the purpose of this video is to demonstrate how to use the latest version of Tycho to generate observations on NEOCP objects. So as an example, we have 2019 BF5, and we can load these images into the program. And the first step is to align the images. My favorite tool for this is Registrar, and I like it because it is scriptable, and therefore it interfaces nicely with the Tycho software. It's also very fast. As you can see, it has already finished aligning the images. And the next step then is to navigate to the folder where it has saved the aligned images. I also like to normalize the images, and what that does for us is it provides a consistent level of brightness from one frame to the next. It's not required on all data sets, but I like to do it just in case. Next, we are ready to perform plate solving. We specify a lower and upper bound on the plate scale and click OK. What's nice about version 2.4 is that you only have to plate solve the first image. And as you can see, it is already finished, so it makes things very fast. Next, we are ready to input the images into the tracker. The first step in this process is to specify the threshold for star subtraction. We have two sliders for this. We have the coarse adjustment and fine adjustment. As you can see, small changes and coarse adjustment translate into large changes on the display. Once we have it dialed in, we can then click OK. And the next step is to adjust the sensitivity threshold. Small values here for the sensitivity threshold permit fainter objects to be detected. However, it also results in more false detections. For our purposes, for this example, a threshold of 20 is sensitive enough, so we click OK. At this point, we now specify what kind of object we wish to detect. Since this is a NEOCP object, we already know roughly the speed and position angle. If you're not sure, you can always use the Find Orb software and load in the observations of the object in question. In this example, we know that it has a velocity of 2.43 arcseconds per minute, or arc minutes per hour, same thing, and a position angle of 220. So we can specify a lower and upper bound on the speed. I have done that here. I specified 2.3 and 2.5, and position angle of 210 to 230. Now, previous versions of Tycho, you also had to figure out what these start, stop, and step size parameters had to be. But version 2.4, it computes a default value for you. The only time when you need to change these is if it returned a number of motion vector equals 0. So to demonstrate that, if I were to put in a speed of 100 to 110, as you can see, it identifies 0 motion vectors for that kind of speed. And that's because your start movement is too slow. If you wanted to actually search that kind of speed, then you would change it to something much faster. And indeed, this indicates now we have 33 eligible motion vectors. But we do not need that kind of search space. We do not need to search objects having that kind of speed. So we use the default in this case, and it works just fine because, again, as you can see, it returns 92 motion vectors. Now, by default, the granularity is 67%, and that yields 50 motion vectors. And because this is so few motion vectors, really, it's not going to take any time to process. We can adjust this granularity a bit more if we want to. It's not required, but we can. And so I'm just choosing 80%. So that gives us a few more motion vectors to try out. Again, this is not going to take any time at all, so why not go ahead and increase the number of motion vectors? So I click OK, and again, as you see, it's very quick. It already found the object. It's track number 1. So we're now ready to generate observations on this object. So the first step here then is to load star catalog, which I've done. Then we optimize the track, and that gives us better measurements. And just in case you're not sure if this actually is a true detection, you can animate. So this certainly looks like a true detection to me. And so finally, we are ready to generate the observations. This is just saying that not all tracks have been optimized, but we went ahead and optimized the track that we care about, so that's fine. So again, what I did here is I went to verify track, and this pops up a dialog box, and it creates 3 stacks that it animates, and so again, it reinforces the idea that this is indeed a true detection. So we want to go ahead and create observations. So I go ahead and give it the designation, and I click OK. So it has now created the 3 observations from these 3 stacks. If we wanted to, we could create just 2 observations, and the circumstance in which you would want to do just 2 is if you're not getting very good signal on the object. So if it's a very faint object or you just don't have very good signal on it, then you might want to just use 2 observations. But we have a very bright object here, so why not go ahead and create 3 observations. Now that it has created these observations, you could generate a report. So I could do either one of these, as you see here. And it's going to use the information that you populated in your observatory settings dialog box. But what we want to do here is we want to say, well, are these measurements actually good? So we can compare it with existing observations. And as you can see, it has downloaded the observations for this object. So this object was already submitted, and these measurements were made using another tool. So we'd like to compare if the measurements in Tycho are reasonable. So first off, let's look and see what the residuals are for the submitted observations. So I will view and find orb. And as you can see, we have a 0.62 is the highest residual of these 4 observations. So 0.62, and the others had 0.59, 0.46, and 0.58. So keep that in mind. So now let's see how the observations in Tycho compare. So again, we use find orb, and we scroll down. And as you can see, the highest residual here is 0.49. The other observations have 0.24 and 0.27. So I think that compares favorably. In other words, Tycho is generating observations that are of good, high quality. So I hope you liked this video, and I hope it reinforces the idea that Tycho can be used for 2 purposes. Again, it can be used to detect previously unknown objects, but it can also be used for follow-up observations of already known objects, as demonstrated in this video. So, hope you enjoyed watching. Thanks for your time. See you next time.